Okay, Chapter 0, Section 6, Factoring. So in this section, we're going to learn how to factor polynomials. We're going to learn 5 different techniques. Factoring common factors, factoring by grouping terms, special factoring formulas, factoring trinomials of the form x squared plus bx plus c, and finally factoring trinomials of the form ax squared plus bx plus c. So I recommend that we learn and apply these techniques in this order. We start with the easiest thing you could do to factor something, the common factors, and build our way up through the most challenging thing that you could do is to factor trinomials of the form ax squared plus bx plus c. As you'll see, that one is a lot of work. So when you are staring at a polynomial and you're trying to factor it, go through these in this order. Think about common factors, then think about factor by grouping, then think about special factoring formulas, then try number 4 and number 5. Okay, so the first one. So factoring. We learn how to multiply polynomials, right? And so in math, whenever you learn how to do something, there's usually, usually we try and figure out how to undo it, right? So we learn how to add, and then we learn how to subtract, then we learn how to multiply, then we learn how to divide, right? So we learn how to multiply polynomials. So now we have to kind of learn how to undo that. In general, I would say factoring is a lot tougher. It's pretty tricky to factor polynomials, depending on the polynomial. But yeah, they can be real tricky. So it takes a little bit more effort to undo the multiplication process. So, for example, in the previous section, we learned how to multiply. So we could do, say, the FOIL method on something like this, right? So we can multiply this times this one times that one, this one times this one times that one. We get our red claw, and we FOIL it out, F-O-I-L, FOIL it out, and reduce. And then finally we get to this, right? So in the previous section, when we multiply in this direction. But now we want to start here and go in this direction. That process is called factoring, right? How to rewrite a statement like this one as a multiplication of simpler polynomials, smaller, simpler polynomials. Is the process of factoring, right? So we say that, this should be in parentheses, we say that x minus 2, a little unit, a little binomial, and that x plus 2 are factors of x squared minus 4. Okay, all right, so I would recommend that you do them in this order. Whenever you're facing a polynomial, I would recommend that you tackle that process in this order. Try using common factors, then try factor by grouping, then think about special factoring formulas, then factoring trinomials of the form x squared plus bx plus c, and then finally, if the other ones don't work, then try factoring trinomials of this form, ax squared plus bx plus c. And then again, you might have to repeat. Maybe you simplify it by finding common factors, and then maybe there might be more than one step. Maybe you might have to repeat. Okay, so let's go through each of these. All right, factoring common factors. This is the easiest one. So the easiest type of factoring occurs when the terms have common factors. So for example, let's look at these two. So for the first one, what we want to do is just identify the terms. So let's highlight the terms. There are 2 different terms here. There's this term here, 3x squared, and this term over here, 6x. So all we have to do is identify which numbers are common and which variables are common to both terms, and then do the reverse of distribution. So all we have to do is recognize that between the 3 and the 6, they both have a common factor of 3. And between the x squared and the x, they both have at least one common factor of x. So we just factor this as 3x. Well, okay, just this one time, let's just do it a little bit longer. So I'm going to rewrite it as 3x times x minus 3x times 2, right? Because 3x times x is 3x squared, and 3x times 2, that's 2x. And so now we can easily see that this and this are the same. So we're going to pull it out, kind of the reverse of distribution. So let's put a little equal sign there. And so this is equal to 3x, parentheses, x minus 2. Good. So we pulled this out. So it's the reverse of distribution. If we wanted to distribute, we would multiply this times this and this times that, and that would get us back to where we started. Good. Okay. So here's our answer. It's 3x, x minus 2, and there's really not much else we can do from there. So we've rewritten the original statement as a multiplication of 3x times x minus 2. All right, same thing for this other one. Let's see, we have to figure out what they all have in common. So first, let's tackle the number. There is an 8, there is a 6, and there is a 2. So clearly, the 2 is the most that all three have in common, since it's the smallest number and it's also a prime number. So there's no way to break that down any further. Therefore, the 2 is the number that is common to all of them. Instead of, oh, that's fine. I'll do it one more time this way. Usually, I skip this step here, rewriting it this way, and go right to this step. But one more, I'll do it this way one more time. So a 2 is what they have in common. Common term is going to be 2. Now the x, let's see, we have x to the power of 4 there, x to the power of 3 there, and then x to the power of 1 there. So again, the smallest value being a 1 is the one that they all have in common. So we're going to put an x here. And now for the y, we have a y to the second power there, a y to the third power there, and a y to the fourth power there. So now y to the second power is the smallest that they have in common. So y to the power of 2. So here is our common term. Again, I normally don't do this step, but just to really drive home the idea, I'm going to rewrite this, each of these, rewrite this whole trinomial with a common term in place. So it'll be 2xy squared, and now 2 times 4 gives you an 8, and there used to be x to the power of 4, and we took 1, so this would be x to the power of 3, and then y to the second power is right there, plus, and then I'm going to write 2xy squared there, and now there is a 3 times 3 x squared y to the power of 1 minus, and then 2x squared, 2xy squared, 2xy squared times y to the power of 2. Okay, so now it's really easy to see that common term right there, right there, right there. And now we can do the reverse of distribution. Put the 2xy squared out there. And now, usually do this. Right? So usually I skip this middle step and jump to this, where I write down the common term out here. And then I put the signs, the plus and the minus right in there. And I think to myself, this times this blank right here, has to be equal to this first term. And that's how I arrive at this 4x to the power of 3. So 2 times blank equals to 8, so that would be a 4. And then x to the power of 3 times x equals x to the power of 4. And then times 1, because y to the second power times 1 is y to the second power. The middle term, blank times 2 equals to 6, so I put a 3 there. And then x to the power of 2 times x to the power of 1 results in x to the power of 3. And finally, a y to the power of 1 it times y to the power of 2 gives me my y to the power of 3. So that's how I get that. And then finally, 2 times 1 gives you that. And x and y to the power of 2 is the only thing that's missing. Right, so that's how I normally factor common terms. I kind of skip this middle step and do it this way. And then maybe just a final kind of polish. 2x y squared 4x cubed plus 3x squared y minus y squared blank. Okay, so should be really easy. Factoring common terms, factoring out a common term should be the easiest way for you to factor, and that's why it's the first one on my list. Tackle that first, simplify things down. And then once you've done that, re-examine your result and see if maybe there's a way to break it down any further. Here, x minus 2, clearly there's nothing else we can break that down into. But here, maybe there's a way to break that down a little bit further. So then continue on your list of things to do. Good? Okay, so now the second thing you want to do is factor by grouping. Okay, factoring by grouping terms. So this process works when there is at least 4 terms, and it works based on the following idea. So let's go back to multiplication. So for example, if you remember multiplication, if I had, say we had x plus 3 times a y minus 5, let's say. Okay, one way that we can multiply this is by foiling, of course. So we could use this times this, and this times this, and this times that. So there's our red lobster claw, and we can foil F-O-I-L, right? And so we end up with x times y minus 5x plus 3y minus 15. Okay, so that's the correct answer. But there's also another way that we could do this. And maybe you recall that another way to do this is to distribute this entire thing across the second one. So we're going to take the x plus 3 and multiply it times this, and then take the x plus 3 and multiply it by that guy. Okay, so that will result in x plus 3 times y minus x plus 3 times 5. Good. Then we do distribution one more time. And this looks a little funny because of the way I wrote it. I should have put this 5 out in front because we want to make sure to carry this minus along with the 5. So I'm just going to rewrite it this way. Let me put this guy over here and put it out in front like this. So 5 times that, and that way I don't forget to distribute the minus. Okay, so next we use distribution one more time and multiply y times x and y times 3. And then we distribute this minus 5 to the x and to the positive 3. And so again we get yx plus 3y minus 5x minus 15. And it's pretty much the same answer as that one, except maybe just switch some stuff around. Remember, the order doesn't matter as long as we carry the sign. So minus 5x is that second term there, plus 3y is the third one, so it looks the same. So we could do it this way, we could do it this way, and likewise, we could also distribute in the other direction. So maybe we could have x plus 3 times y minus 5, and maybe this time I could take this term and distribute it across the first one. So this whole thing multiplied times the x, and this whole thing multiplied times the 3. And so that gives us a x times y minus 5 plus a 3 times y minus 5, right? So again, we distribute the second binomial across the first binomial, multiplication distributed across addition. And then once again, we use distribution to distribute the x and then to distribute this 3. Good. So we end up again with xy minus 5x plus 3y minus 15. Same answer as before. Okay, so all of this was multiplication. Multiply. Okay, so now we want to learn how to undo the multiplication process. And so if you notice that in all of these cases, well, it's the same question, just done in different ways. But in this case, our result ends up in 1, 2, 3, 4 terms, right? So that's when factor by grouping works. That should trigger something. If you notice that the polynomial has a minimum of 4 terms, maybe more, but a minimum of 4, and usually 4 is what we run into. So 4 terms, and we want to reverse this process. Notice that if we look at it through the lens of the FOIL method, it would be hard to undo it, right? It's just hard to think about this FOIL process this way. But if we look at it through this process, then we can. So what we notice is that there's 2 distributions that need to be undone, reversed. 2 distributions that need to be reversed. The first one happens right here. If we want to go backwards, we have to notice that the first 2 terms have a y in common, and that the last 2 terms have a minus 5 in common, and that'll get us in reverse up to this stage. And once you get to this stage, we just have to recognize that this term has an x plus 3, and this term also has an x plus 3, and then we undo that process to get to there. Okay, so let's practice this. Okay, so here's a couple of examples for us to practice. Notice that there are 4 terms, 1, 2, 3, 4, and there's no way to reduce them. So because I see 4 terms, that should let me know that the factor by grouping process might work. Now, it's not guaranteed to work, but it might work. It's worth trying as the second thing. Well, actually, remember, we want to go in order. So the first thing you want to do is think about common factors. Is there a common term, a common factor between all of them? And they all 4 terms do not share anything. They don't share a number. There's no number common to all 4 of them. There isn't a letter common to all 4 of them, so there's no way to simplify this one any further. Same with this one, looking ahead. There isn't a single number or letter that is common to all 4 terms, so that doesn't really simplify it for us. If there was something that they all shared, like for example, if this one also had an x there, we could say, oh, they all have an x, let's factor out an x, and that would simplify the process for us. Or if these 2 had something that is a factor of 4, then that would also simplify things for us. Okay, so looking at this guy here, what do they have in common? So for factor by grouping, we're going to do the following. Number 1, you got to group them up. I like to underline them. Do not put parentheses because that might mess up signs, but I like to underline them. So I underline the first 2 terms, and I just focus on those, factor that out. What do they have in common? So they both have an x squared in common. So I factor out an x squared, and what remains is an x there plus a 1. Right? So just factoring out the first 2 terms by itself gives you this. Good? That's step 1. Factor out the first 2 terms. Step 2, I like to put a plus blank copy. So I put an x squared, x plus 1. Then I put in a plus and a blank. Step 3, I put x squared, x plus 1 plus, and then I put a copy this term right here, x plus 1. Okay, so factor out the first 2 terms. I did that. Then I put a plus blank. Good. And then I copy this binomial right there, whatever it is, right? So far, I have not focused on the last 2 at all, not until step 4, right? Step 4, like this, plus blank copy. And now this is when I finally focus on the last 2 terms. I want to fill in this blank such that whatever value goes there times x gives you this first term, 4x, and blank times this 1 gives you that last term. So hopefully there's a value you can find there. So in this case, it's not too bad. It's a 4. right? 4 times x gives you 4x, and 4 times 1 gives you a 4. Good. All right, so let me get rid of this underline thing now because it looks weird. Okay, so now that I got my blank filled in, the final step now is to realize that I can do the reverse of distribution with these two, right? These two terms have an x plus 1 in common. I want to reverse that distribution process. So now I can copy it this way. Step 5, factor out the x plus 1. So x plus 1 comes out here, and what remains is an x squared plus 4. There. So we factored it. Good. So these 5 steps is what I would recommend for factoring by grouping. Focus on the first two terms. I like to underline them. Do not put a parentheses in there because that might mess up your sign. We'll see in the next one an example involving signs. Okay, so focus on the first two. Factor what they have in common. In this case, they have an x squared. We have x plus 1 remains. Then put in a plus blank. Then we copy down whatever binomial you got from step 1. You copy it down over here, leaving that blank there. Then you find the value that goes there, right? You have to think about the number, or there might be some variables there. Whatever term makes this a true statement. You're looking for a true statement such that this, in this case a 4, times x equals 4x, and 4 times 1 equals to a 4. And then finally, you factor out the common binomial that results way back here in step 1. Okay, so that's the factor by grouping process. So I'm going to do it one more time over here, but I'm not going to space it out quite as much. So a little bit less notation. So again, I start by underlining the first two terms. Okay, what do they have in common? So I think to myself, all right, well, they have a x squared in common. So I'm going to put x squared, parentheses, x minus 2, right? So x squared times x gives you x cubed, x squared minus 2. So x squared times 2 gives you a minus 2x squared. Okay, remember, I always put a plus blank, copy x minus 2, and then I fill in the blank. So I haven't really focused on the last two until this stage, and now the last two, I got to think what can go in here to make this a true statement. Blank times x equals minus 9x, so that's got to be a negative 9. Negative 9 times x gives you a minus 9, and negative 9 times negative 2 gives you a positive 18. So it works out. If you're wondering, well, what happens if it didn't work out? What if the original question here had a minus 18? Then the minus 9 wouldn't work, right? So if the original statement was x cubed minus 2x squared minus 9x minus 18. See, if we had a minus 18 right there, then we'd be in trouble because we'd need a negative 9 here to multiply times x to give you this term, but then negative times a negative gives you a positive, so then it wouldn't work out. So the answer is that it wouldn't work out. It might not factor. Like I said, factoring is pretty hard, and a lot of times you run into polynomials that just don't factor or don't factor nicely, or they might need something more advanced, more sophisticated, more difficult, or they might factor into something that doesn't have pretty numbers, right? There might be some ugly decimals going around. There might be some imaginaries that happen, some irrationals. So it could be a more complicated statement. So hopefully at this stage, we're just learning. Your author will cherry pick some good ones for you. So most of them should work out, but just be aware that there's a lot of polynomials out there that don't play nice. Okay, so luckily for us in this case, this is another case where okay, so luckily for us, this does work out. And so now I just clean it up a little bit. So this is going to be next I go ahead and factor this and this, right? I realize that both terms have an x minus 2 in common. I factor that out. And so that will result into x minus 2 parentheses, and then there is an x squared, and then it's a plus minus, so it's just going to be minus 9. Okay, so I finished the factor by grouping process, so we're done with that. But then some of you might notice that this can be factored further. Follow the 5 factoring techniques in that order, but you might have to do more than one of them. You might have to repeat things. So this leads nicely into the third method for factoring. Okay, the third process, the third factoring technique is going to be factoring using factoring formulas or special factoring formulas. Okay, this process is really just to remember some common ways to multiply, some common patterns that we learned when we were multiplying polynomials. So if you recall, when we were multiplying binomials that fit this form, an a minus 5 times an a plus 5, we could FOIL all this. We FOIL it, and then the middle terms cancel out, and so they give you this. Likewise, if we had something of the form a plus b parentheses squared, again, we can FOIL it all out, and it gives you this pattern, a squared plus 2ab plus b squared. And likewise, if we had a minus b parentheses to the power of 2, then again, we can FOIL this out, and it leads to this. So there's just some cute little patterns. When we were doing multiplication, it was just kind of a nice little shortcut to realize that we could just follow the formula to expand it all out. But it wasn't really necessary with multiplication because it was just as easy to do FOILing. But now in the reverse of the multiplication, when we want to factor, now those patterns become really, really useful. So what we're going to be doing is working with something that fits this form, realizing it fits the form, and then going this way, right? So for example, the first one, let's do an example for the first one. So we saw that if we had like x plus 3 times x minus 3, right? If we were multiplying these two binomials, they fit this form, a minus b times an a plus b, well, in the other order, but it doesn't matter. One of them has an addition, one of them has a subtraction, everything else is identical. We can FOIL this, right? We can get our red claw out and figure it all out. Or we can go, okay, it fits this form, so therefore its expansion, its multiplication is going to fit this form. So this is going to be equal to x squared minus 9, minus 3 squared. Okay, but now we want to go backwards, right? We're going to be given an x squared minus 9, and we're going to ask to factor it. And then that's when we have to realize that this is actually x squared minus 3 squared, a difference of squares, right? Difference of squares. And then that's when we realize, oh, I remember this pattern. So we just break this down into x plus 3, x minus 3, right? So this is really the factoring technique that just relies on remembering some patterns. The first 3 should be very common to us by now. The last 2 are not so common. We don't really use them that often in multiplication, but they are used a lot more in this factoring process because they result in a nice little pattern. So if we multiply x minus b times x squared plus ab plus b squared, right? If we do a multiplication, a lot of those internal terms are going to cancel out. And what results is this, a cubed minus b cubed. And same thing for this one. So there's some nice patterns that emerge. So again, we will be given something that fits the left-hand side here. We just have to realize or remember that it fits one of these patterns and then use this cute little shortcut process to factor them. Okay, so for example, let's say we're asked to factor these two. So for the first one, we have x squared plus 6x plus 9. So again, we go through our little sequence. Number 1, common factors. Is there anything that they all have in common? No, right? There is no letter that all 3 terms have, and there is no number that all 3 terms have. So that doesn't work out. Factor by grouping. Well, we need 4 terms for factor by grouping. There's only 3 terms, so we can't do that one. Number 3, does it fit a particular pattern? And for me to assess whether it fits a particular pattern, I like to rewrite this in the following way. I like to, write the first term and the last term as something squared. Well, this one's easy because it's just x squared, but sometimes it gets a little more complicated. Okay, so it's the first term squared, and then I put some space there, a gap, and then I go plus, and then the last term squared. So I rewrite it as a squared term. So this would be 3 squared. And then I ask myself, is it true? Okay, I'll put it in steps. Step 1, do that. Step 2, let's copy this down, x squared, and then plus 3 squared. And then I fill in the blank here and I ask myself, is it true that the middle term here is equal to twice the 2 terms that you're squaring? Is that true? Right? And then put a plus there because there's a plus there. And yeah, that makes it a 6x, which is that guy, right? So it's true. So I'm going to rewrite this as my A. Here is my A, and here is my B, and then here is my A again, and here is my B. And so this is the form a squared. This fits the form a squared plus 2ab plus b squared, right? So remembering our pattern, we know that this is equal to a plus b parentheses squared. So I know that this factors as 3, my final answer. This factors as x plus 3 parentheses squared, right? Just because it fits that form. And you can always double check it after that. Guessing and checking is always useful. So if we FOIL this out, we see that we get the same result. Okay, let's look at the second example. All right, same thing. I want to rewrite the first term as something squared, rewrite the last term as something squared, then ask myself, is it true that the middle term fits that? So let's put it over here. So the first term is going to be 2x parentheses squared. I'm going to write it as something squared. The last term, well, plus y parentheses squared. And then I ask myself, is it true? Okay, I put a subtraction there because there's a subtraction there. Is it true that this term is twice the 2 things that I'm squaring? Like that. Is that true? And if it's not, like you might ask yourself, what if this wasn't a 4? What if this guy was instead a different number? What if the original question was 4x squared minus 5xy plus y squared? Well, then at this stage, the answer to my question would be no, it doesn't fit that form. And then, well, you can't factor it this way. You have to do something else. So people always get a little confused when I do this process here. They think I'm doing something to it, and I'm not. I'm just checking, right? I'm just checking. Is it true that 2 times the 2 terms that you're squaring, does it fit the middle term, right? And if it fits it, great. You found a way to factor it. And if it doesn't, then there's nothing you could really do to force it. You'd have to try a different factoring technique. Try something else. Okay, so in this case, it does fit. 2 times 2 is 4, and then we have an xy, so it does fit that. So it does fit our pattern once again. So in this case, this is the A right there. This is another A right there. This is my B, and this is the other B. So this fits the form a squared minus 2ab plus b squared. Good? All right, so then I can just jump to my answer now and say that my factoring, my result is that this fits the form 2x minus y parentheses squared. Good. And again, you can do a little bit guessing and checking and confirm that when you FOIL this whole thing out, you get that guy right there. All right, let's look at a couple of other examples. So 27x cubed minus 1. Okay, so we go through our process. Number 1, can we factor out a common term? And well, in this case, they don't really share anything since the second term is just a 1, so that doesn't work. Number 2, factor by grouping. We need 4 terms. We only have 2, so that doesn't work out. And then we get to number 3, which is factoring through our patterns, right? Looking for perfect squares and difference of squares and difference or sum of cubes in this case. All right, so what you want to notice is that this, again, fits a particular pattern. I can rewrite the 27 as 3 to the power of 3. So this first term is really 3x parentheses to the power of 3 minus, and then the 1, we can do a little trick where we can rewrite it as 1 to the power of 3. Good. So we have a difference of cubes here, something cubed minus something cubed. And so now if we look at our little pattern, we notice that when we have a difference of cubes, they fit this form. They fit this form, right? A difference of cubes, so it's going to be an a minus b times an a squared plus ab plus b squared. Right, so I'm just going to recognize that it fits this form and just copy it down this way. Okay, so this is my A, this is my B. So we have A cubed minus B cubed. And I know that this fits the form A minus B parentheses, and this would be A squared plus AB plus B squared. So following that pattern, I know that 27x cubed minus 1 is really equal to 3x minus 1 parentheses 3x squared plus 3x times 1 plus 1 squared. Just filling in that pattern right there. And then I can just simplify this a little bit. This is 3x minus 1. And then this is going to be 9x squared. 3x times 1 is just 3x, so plus 3x plus 1. Good. And like before, you try one factoring technique, you simplify it, and then you might have to repeat it, right? Like this, maybe this factors some more. So you have to keep trying the different techniques until you've factored it all the way out. But for now, we're going to pause here because we haven't talked about how to factor something that fits this form. That's coming up next. All right, let's take a look at this one then. So again, this one, we would go through the process, common terms. They don't have any common terms. Factor by grouping, we can't do that. There's only 2 terms. We need 4 for that. So then hopefully at this point, we look at our patterns and we realize that this can be rewritten as something that fits the form of a sum of cubes. Right, so this first term can be rewritten as x squared parentheses to the power of 3 plus this next term could be written as 2 parentheses to the power of 3. So it's the sum of cubes. That could be a little tricky to realize sometimes, so it takes a little bit of practice, but sometimes it's hard to identify these patterns. Okay, so it's just a sum of cubes. So that's where this is my A and this is my B. And so I know that A cubed plus B cubed, I know that that's going to be equal to A plus B, and this is going to be A squared minus AB plus B squared. Notice the pattern here. When I have subtraction here, then this first binomial has a subtraction there, and then it has a plus right there and a plus right there. When we have an addition right there, then that is an addition there, but then this one is a minus. So I always remember it by just remembering that these two are opposites. So when I want to factor this one's the same as that one, right? Same here. I want to factor a sum of cubes, so the little binomial has a plus, and then these two are opposite sign. Right? So same, then opposite sign. Hopefully that'll help you remember the little pattern. Okay, so now I just apply this pattern right here. This is going to be equal to A plus B, where A is x squared. So this will be equal to, let's copy the whole thing down, x to the power of 6 plus 8 then is equal to x to the power of 2, x to the power of 2 plus 2, parentheses, x to the power of 2, parentheses squared, minus x to the power of 2 times 2 plus 2 squared. Okay, and so we can simplify that as x squared plus 2 times x squared squared is x to the power of 4 minus 2x squared plus 4. Okay, factoring trinomials of the form x squared plus bx plus c. Okay, notice very importantly that the constant in front of the x squared term is, well, there's nothing there, so by default there's a 1, right? There's like the little invisible 1 right there. So 1 times x squared, or, you know, obviously if there's nothing there, by default then it's just a 1. So we're looking at cases where there is definitely a 1 right there, and they fit this form. If there was something else there, like a 4, a 9, a 5, whatever, then that's the last technique we're going to cover, factoring trinomials of the form ax squared plus bx plus c, where a is not equal to 1 and obviously not equal to 0 either. Okay, so for now, let's focus on these, factoring trinomials of the form x squared plus bx plus c. Okay, to factor trinomials of this form, we notice, again, a pattern that happens when we FOIL, right? When we FOIL, you know, if we tried our good old-fashioned foiling technique on this guy, we multiply this times this, that would give you this term right here, the f. Then we multiply the x times the s, which would be this, x times s. And then r times x gives you r times x. And finally, there is an r times s term, which is this last one over here. So it's grouped this way so that you realize that when you're given something that fits this form, what we're looking for is a multiplication of two binomials where the x and the x are there because they give you the first term, x squared, and the last two have to be a situation where where the r times the s is the last term, and the r plus the s gives you the middle term. Good. So, for example, let's again look at multiplication. Notice that if we were asked to multiply x plus 3 times x plus, I don't know, say 5, then we apply our foiling technique, and we end up with x squared plus 5x plus 3x plus 15. Right? And then those middle terms sum. So just to make it fit that pattern right there, I'm going to rewrite it this way. Plus 5 plus 3 and x. Plus, and then I'm going to keep it as a 3 times a 5. 3 times a 5. Okay? So this thing is just letting you notice that this, the role of r, is right here and right here. So this is this r value. This is the r from there, right? So this is r, and this is r. And finally, this guy right there is the s value, which appears right there and right there. So that one's S, and that one is S. Good, good, good. Okay, so if we are given, so multiplication's not so bad. I was just rewriting it so it fits that form over there. So now if we're given this question, right? So given this guy right here, if they give us x squared plus 8x plus 15, and they ask us to factor it, now we have to realize that what we're looking for is for two numbers such that the last term here is the result of multiplying those two numbers. So we're looking for r and s. When we multiply them, r times s we get the 15, right? So the multiplication results in this last term. And when we add them, r plus s, we get the middle term of 8. So this requires a little bit of guessing and checking, but as you can see, the 3 and the 5 fit that form, right? So we know that 3 times 5 equals to 15, and we know that 3 plus 5 adds up to 8, which are the two values that we get right in here, right? Two numbers that multiply to 15 but add to 8. That's where 3 and 5 come in. Takes a little bit of guessing and checking. So this is kind of the guessing and checking process, really. And so that's how we arrive at our factorization of this, right? So given this trinomial, x squared plus 8x plus 15, we know we want to break it down. It fits this form. Notice that there's a 1 in front, 1 times x squared. So it fits this form, and we just have to kind of guess and check our way to find the numbers 3 and 5. Okay, so again, your author picks some nice polynomials that work out nicely. This process really only works as long as those numbers are manageable. You can find the two numbers and multiply to 15 and add to 8. If it's a really difficult one, then it would be kind of hard to do it this way. So we might have to use a different technique. Okay, let's look at another example. So for example, if we're given this one, right? So this time we don't know what the answer is ahead of time, but it fits the form. Again, notice that there is a 1 in front, right? By default, there's nothing there, so there's a 1. So this is going to work out for us. It's going to fit that form. So what I want, and usually I just start by writing it down. I start by writing x, put a blank there, big space there, times x, put a big space there. Now, you could put the plus. Well, sometimes I just put the pluses and then realize that what goes in here could be a negative, so it could end up being a subtraction. But we're looking for two numbers, right? So this is where my r would go, and this is where my s would go. I'm looking for two values, r and s, such that when I multiply them together, they give me 12. So find r and s such that when I multiply them, r times s, we're going to get 12. And when I add them, r plus s, I'm going to get a 7, right? And this is the guessing and checking process. 12 is not bad. There's only a few ways in which we can get two numbers to multiply to 12. So we can just list them all. There's 1 times 12, obviously. There's 3 times 4. That works out. There's 2 times 6. That works out. And that's it. That's the only, these are the only 3 ways in which we can multiply two values to give us 12 with positive whole numbers, at least. There's more complicated things, right? Can also get into fractions, like 1/2 times 24, for instance, also equals to 12. But then that gets more complicated, right? So usually we want to stay away from fractions if we can. If the original question has fractions, there's no way to get to them. But initially, they're not so bad with nice whole numbers, and then eventually they get into fractions and stuff like that. So that's, a little bit more challenging, especially since the next step is going to be to figure out that their summation adds up to the middle term, which in this case is 7. So I know that this one is going to fail because 1 plus 12, that's 13. That's not going to work out. And I know that 2 plus 6 is 8. That's not going to work out. But then, of course, the 1 plus 4 does equal to 7. And that's how I know that this can't be the answer, that can't be the answer. There's my answer. Good. So then I can come back over here and fill in the blank, make sure that the signs and everything work out. So I could say that this is equal to x plus 3 and x plus 4. And again, you can do a little bit of guessing and checking here, so you can confirm that if you multiply this whole thing out, it does in fact give you that one. Okay? All right, so this method, like I said, works out great as long as they're kind of simple numbers. If it's more complicated, then you might need a different technique, but this is a good one to try initially, and it might work out. Okay, so a slightly more complicated method would be factoring trinomials of the form ax squared plus bx plus c, where the a, this value out in front, is not a 1, because if it was a 1, then it would be like the previous case. And it's not a 0, because if it's 0, then this whole term would be 0, and then you're looking at a much simpler situation, right? So this is where a does not equal to 0. I should have included it on here, actually. This is where a does not equal 0, and it doesn't equal 1, of course. Okay, so to factor trinomials of the form ax squared plus bx plus c, where a does not equal to 1, we're going to use something called the AC method. The AC method refers to writing a trinomial in this form where the a, the b, and the c are constants, right? So we have an a is the constant in front of the x squared term, b is the constant in front of the x, and finally c is this last constant out here. So the AC method refers to this, the a and the c, because that's step 1 of the AC method, to multiply the a times the c. Okay, so to illustrate how we're going to do, or how we're going to use the AC method, I'm going to start again with multiplication and then learn how we're going to undo that process. So let's say, for example, that we are back in the chapter on multiplication and you're asked to multiply 2x plus 3 times, say, 5x minus 2. Okay, so not too bad as a multiplication problem, right? Again, we can use our little FOIL technique. F-O... Right, we can get our red lobster claw on the case. We got ourselves FOIL, right? So then this will result in 2x times 5x, that gives me 10x squared. 10x squared. Then this is a minus. So 2x times negative 2, that gives you minus 4x plus 15x minus 6. And then we combine the middle two terms to give us 10x squared plus 11x minus 6. Okay, not a difficult multiplication question, but now if we're asked to go backwards here, factor this guy, that can be a little challenging. So let's figure out how to undo this process to get back to this using the AC method, right? So now, given that we have 10x squared plus 11x minus 6, we're asked to factor this. First, we're going to notice that it fits this form, right? So here, the a is a 10, the b equals to 11, and carry the sign with it, the c is this negative 6. Okay, step 1 in the AC method is going to be to multiply a times c. Multiply a times c. Multiply a times c. Okay, well, in our little case, that would be 10 times negative 6. To give you negative 60. Okay? Step 2 in the AC method is to find two values, let's say P and Q. Find two values, P and Q, such that when we multiply P times Q, we get the AC value from step 1. So in this case, we're looking for something that equals to negative 60. And we're going to require that these two values we find multiply to negative 60, but also they add up to the middle term, in this case, the 11. And P plus Q add up to 11. So this is a lot like what we were doing before when there was a 1 there. We were looking for two values that multiplied to the last constant but added up to the middle constant. But in this case, we begin by multiplying the A times the C first. We get this number. And now we're looking for two values that multiply to negative 60, add up to 11. This is the hard part. This could take a little bit of guessing and checking until you get to the right one. And don't forget about the sign. You have to also pay attention to the sign. So we're looking for two numbers that multiply to 60. So obviously the way we got there was 10 and a 6. So that's always one option. 10 times 6 equals positive 60. So I can make one of them negative, and I would get to negative 60. But then I know that when I add 10 plus 6, that adds up to 16. And if I make one of them, I got to make one of them negative to make that a negative, right? So if I make the first one a negative, right, we get a negative 60 there. Then make that a negative. They add up, negative 10 plus 6 adds up to negative 4. Adds up to negative 4, not 11. So that doesn't work out. And even if I decide to make the negative on the other number, so 10 times negative 6, that's still negative 60. But then I have 10 plus negative 6, that adds up to positive 4, still not 11. So that doesn't work out. Okay, so we can try different things. Two numbers that multiply to give me a 60. Well, that could get a little tricky. So in fact, you might want to do a tree for this thing. If the numbers are small, you can just kind of figure it out and try different things. Otherwise, you might want to do a factorization tree. So I'm going to factor out the 60 into 10 times 6, because that's an easy way to know what 60 is, okay? And now this breaks down into a 2 and a 5, and this breaks down into a 2 and a 3. So the prime factorization of 60 is 2 copies of the 2, 1 copy of the 3, and 1 copy of the 5. So this gives me a nice organized way to find all the different ways in which two numbers multiply to 60 by regrouping these things. So I can tell, for instance, that one way would be if I leave just the 2 alone and put all the other terms over here, 2 times 3 times 5. That would make it 15, and 2 makes it 30. This is 30 times 2. Yep, 30 times 2 does equal 60. Or I can put 2 of those 2's together and put the rest over there. That's 3 times 5. Okay, so 4 times 15, that's also equal to 60. Or I can put a 2 and another 2 and a 3 together and leave the 5 over there. That's going to be 4 times 2, that's 12. 12 times 5, that's also equal to 60. Or I can put, figure out all the ways we can recombine these. I can put a 2 and a 5 together and leave the rest over there. So then there would be a 3 and another 2. So 2 times 3, that's 6 times 10. So you can see how we can continue along this way and come up with all the different ways in which we can find the values, two numbers that multiply to 60. Good. Here, let me put these in different values to make sure. 2 times, and then 2 times 3 times that. So this one is leading. So this one is leading to 2 times 15 times 2. This is 30. 2 times 30 is 60. This one is saying 4 times 15. This one is saying 4 times, that's 12 times 5. And this one is leading me to 10 times 6. Okay, and then of course don't forget the obvious one, 1 times 60. And going back over here, guessing and checking my way through these, I can see that this one intrigues me because I have a 4 and a 15. They multiply to 60, and I know that if I add them with one of them being a minus, I'm going to get to my 11. So two general ones to check. Let's say we have 4 times negative 15 and negative 4 times positive 15. Both of these will result in a negative 60. But only one of them will work out to positive 11, right? If we have 4 plus negative 15, this leads to negative 11. Nope, we want positive 11. And then minus 4 plus 15 adds up to positive 11, and there's our winner. Got it, okay? So the numbers we're looking for are negative 4 and positive 15. Now, in the previous technique, when there was a positive 1 there, we looked for two values that multiply to the last constant, and then they add up to the middle term. And then we were done. Once we found those two values, we can just rewrite our trinomial as the multiplication of two binomials with those constants. However, in the AC method, you're not done. You have to find those two values, and then step 3 is going to be to rewrite the original given trinomial, where the middle term is now replaced by the two values that you just found. Okay, so step 3. Step 3 is going to be to take the original statement, which was 10x squared plus 11x minus 6, and you're going to replace this middle constant, the 11, with these two numbers, which you just found. They add up to 11, right? That's the whole goal. We needed to find two numbers that multiply to negative 60, but they add up to 11. So we're going to replace this 11 with that. Okay, so then we're going to write 10x squared, and this becomes minus 4x plus 15x minus 6, right? So I just replaced the positive 11 with a negative 4x and a positive 15x. Good, good, good. Okay, so now step number 4 is to use the grouping technique. So all we've done is find a way to separate the middle term, right? 11x has been separated this way, so that now we have 4 terms, and now we can use factor by grouping, just like we did earlier, okay? So the factor by grouping method Okay, so if you recall, the factor by grouping process begins by focusing on the first two terms alone. I like to underline them. Don't put parentheses because you might mess up the sign. So I like to underline them and focus on just those two terms. What do they have in common? Okay, so they both have a 2 and an x in common. So I like to write that out here. 2x, parentheses, now this becomes 5x minus 2, right? So 2x times 5x gives you 10x squared, and 2x times minus 2 gives you minus 4x. Be careful with the signs. I always put a plus, blank, and then copy this binomial. Again, don't focus on the last two terms yet. That might confuse you. So I just copy this down. That's going to be 5x minus 2. And then I focus on the last two terms, right? So looking at the last two terms, what can I put in here such that I get a true statement when I distribute? Blank times 5x must be 15x. Blank times 2, minus 2 must be minus 6. And so after a little bit of thought, maybe we realize that 3 must be the one that works. 3 times 5x gives you 15x, and 3 times negative 2 gives you negative 6. Okay, so now we just clean that up a little bit. Well, actually, okay, so next we realize that what we have now is a common binomial of 5x minus 2 from both these terms. We can factor that out. And so we get that this is equal to this, which is equal to this. So we end up with a 5x minus 2 out here times 2x plus 3. Good. Okay, and so that's our final result. And so now let's recap what we've done. Let's come back up here. Okay, so we started with multiplication. We started with finding two binomials, these two right here. We FOILed them. We got to this trinomial here. So multiplication wasn't too bad. But then if we want to undo that multiplication process, that's where the AC method comes in. And so we did the AC method, and the AC method results in the same two binomials that we started with. So we were able to undo that process. Just to recap, these are the 5 techniques that we've learned to factor. Factoring out common factors, factor by grouping, special factoring formulas, factoring trinomials of the form x squared plus bx plus c, and finally factoring trinomials of the form ax squared plus bx plus c. Okay, so remember that we want to do these in this order. That I would recommend that you do these in this order. We start off with the easiest thing first, and then leads to the hardest thing. So if you can chip it away with something easy first, that would be good. And remember that you might have to repeat some of these. So maybe you simplify it a little by doing, say, factoring out something that they all have in common, all the terms have in common. But then the result might need more factoring. So make sure you break it all the way down until you get to the simplest form. All right, let's do a couple more examples. Say we are faced with something like this. You're asked to factor 5a plus 1 parentheses squared minus 2 times 5a plus 1 minus 3. All right, our first instinct might be to try and expand this first. FOIL this out, which we can. FOIL this out, we know we end up with 25a squared plus 2 times 5a times 1 plus 1 squared. Just noticing the pattern of a plus b squared is a squared, b squared, twice the a times the b in the center. So I know that this turns into 25a squared plus 10a plus 1. Then distributing this, we get a minus 5a. That makes it a minus 10a minus 2 minus 3. Okay, and then combining some like terms, okay, we get that this cancels with this, and we have a plus 1 minus 2 minus 3. That gives you minus 5 plus 1 is minus 4. So that would be 25a squared, and this becomes a minus 4. Good. Okay, so that kind of works out in this case because this turns into a difference of squares, right? I can rewrite this as 5a parentheses squared minus 2 squared, and I have a difference of squares. So then by our third technique, factoring special products, this is just a pattern that I can remember. So when we have a difference of squares, I know that this is going to be the 5a minus the 2 times the 5a plus the 2. Right? Just remembering that if I have a minus b times a plus b, this is the case where if I FOIL this whole thing out, the middle terms are going to cancel out, and this gives me a squared minus b squared. Right, so in this direction it's multiplication, and this direction it is factoring. So if I notice that I have something squared minus something squared, I know that it factors this way, right? So here I know that this is my a, this is my b, something squared minus something squared, so it'll be a minus the b, a plus the b. Okay, so this worked out nicely in this way. That's one way that you can factor this. But there's another thing that we could have also realized. If we, let me copy this back over here, 5a plus 1 parentheses squared minus 2, 5a plus 1 minus 3. The other thing that we might notice is that it fits a particular pattern. If we think of this as one little unit, this is something squared minus 2 times something. So for example, if I think of it as, say, a giant X here, right? This is the same thing as like x squared minus 2x minus 3. So if we can try and factor that and then come back and treat the x as a 5a plus 1. In other words, I can do like a substitution. I can let x equal 5a plus 1. And so now this we can factor using our fourth technique. It fits the pattern of x squared plus bx plus c, right? Where the b is being played by a -2 and the c is being played by a -3. So we know that if we find two numbers that multiply to -3 but add to -2, we'll find our answer. So this will be x plus blank and then x plus blank there. Two numbers that multiply to -3 but add to -2. Those are easy ones, so might come after just guessing and checking a couple of things. But that has to be -3 there, and this has to be +1 there. I know that they multiply to -3 and they add to -2. Good. So just guessing and checking, the numbers were pretty easy. And now we go back to where we were because we weren't dealing with x, we're dealing with this little binomial here. So now it's going to be -3 there, and I'm going to put a 5a plus 1 there because that's what the x is. And then let's go back away. Okay, and then it'll be blank blank plus 1. And I'm going to put a 5a plus 1 in there. Again, let me highlight it. So this is my x. This is my x right in there. Noticing the pattern there. And now I can simplify it a little bit. 5a plus 1 minus 3. That can be rewritten a little bit. This is equal to 5a minus 2. And then 5a plus 1, that's going to be 5a plus 2. Okay, same answer as before. Good. So sometimes it's useful to notice that something fits a certain form with a nice little substitution like this. You could literally do the substitution, but if you notice the pattern, you can also kind of skip this process of replacing the binomial here with an x. Let's see how your author solved this one. So the author did the same thing. They just didn't do the actual replacement of the letter like I did the letter x. So again, they're saying that there is this and this fit a particular pattern, right? That's this blank, something squared minus 2 times something minus 3. So, this is that blank. And so now, if we think about two numbers that multiply to -3 but add to -2, that's where he got the -3 and the +1 and these blanks that we have to fill in there. And so the blank is this 5a plus 1. And so that's how we get 5a plus 1 minus 3. That's from here. This term right here leads to this term. And then this term leads to this term. Good. And then we simplify by adding the +1 and the -3 to give us -2. And +1 gives you a +2. So there you go. Okay, so that's one technique. Let's try a couple more examples. Okay, remember that when you're factoring, sometimes you have to try more than one technique. Sometimes you have to repeat different techniques until you factor things all the way down to their simplest statement. So for example, let's say we're working with these guys. Okay, so number one, the first thing I would think of is let's factor out a common term. Do they have something in common? They do. They both share a 2 and they both share x to the power of 2. That's the first thing I do, factor out a common term. They both have a 2x squared, resulting in an x squared there minus a 4. Good. And now, looking at this one is the difference of squares. I can rewrite it as 2x squared, and this becomes something squared minus something squared, right? 2 squared is a 4, difference of squares. And by the third technique now, using patterns, using special products, I know that this fits the form x plus 2, x minus 2. The order in which you write them doesn't matter as long as you have one with an addition, one with a subtraction, and that's again just through memory, just remembering the pattern. Good, and now that's as factored as it goes. Same thing with this one. The first thing I'd want to do is factor out what they have in common. They both share one copy of x, and they both share two copies of y. So x and y squared are the common terms I can factor out. So this becomes x to the power of 4 minus y to the power of 4. And again, this is the difference of squares. Something squared minus something squared. X, y squared. And this is x squared parentheses squared minus y squared parentheses squared. Right? Something squared minus something squared. I know that that breaks down into x squared plus y squared and x squared minus y squared. Okay. The sum of squares is not a thing. We can't factor that any further. However, again, we have another difference of squares over here. So this becomes xy squared, x plus y squared. And again, this becomes x plus y, x minus y, again using the same pattern of a difference of squares. Okay, so hopefully that should be enough to help you finish your homework. Please let me know and come by my office hours if you have any questions.